I would like to go through an example with you on section 7.2 where we deal with hypothesis testing for a large sample. And the problem I'm going to go through is on page 383 of your text, and it's number 29, MCAT scores. And we have a random sample of 50 applicants. They have a mean raw score of 31, a standard deviation of 2.5, and they have a mean score, or the claim is that there's a mean score for more than 30, and our alpha will be 0.01. So you can turn to this in your text, and then I will be doing the rest of this as I would a homework problem. Since we know that we are dealing with a large sample, we can go ahead and use the t-test, or I'm sorry, the z-test, and we know that n is 50, x bar is 31, our standard deviation is 2.5, and alpha is 0.01. The claim is that the mean score is more than 30, and so right away I'm going to look at this as more than 30 or greater than 30. It's a mean score, so they're claiming that mu is greater than 30. Now, since that is not a statement of equality, I know that in my first step here where I write my hypothesis statements, that the claim mu is greater than 30 will be my alternate hypothesis. So mu greater than 30. H naught has to include equality, and it has to be everything else. So it'll be mu is less than or equal to 30. The claim, I'm going to denote that by writing claim by my alternate hypothesis. I'm going to draw my curve. It's a normal curve, and it says that mu is greater than 30 on my alternate hypothesis. So what I'm going to do when I put in my critical value and rejection region is I know that since it's pointing this direction, it is a right-tailed test. And I'm not too terribly concerned about making it exactly where it's supposed to be. I just know it's a right-tailed test, so I'm going to give a rough draft and just shade in this area that is greater than 30. This will now be my rejection region, and what I will need to do then is look up my critical value so that I know what to use as a cutoff score here. Since I have alpha is equal to 0.01, and it's a large sample, I know that I can go ahead and look up a z-score associated with 0.01 over here on the right hand side. Now remember, on your calculator you have that normal chart, so I'm going to hit second distribution, turn it on again, second distribution, inverse norm, and since my alpha is 0.01 on the right hand side, I got to put in 0.99 for the area to the left. My z-score associated with the 99th percent, or 0.99 for an area under the curve, would be 2.326. And on these you can usually round to 2 decimal places. I'm going to leave it at 3 right now. So I'm going to go ahead and input or put this in on my chart, 2.326 as my critical value. I'm going to go ahead and input my data under stat, tests, and z-test. Alright, so I'm going to go back up to the top where I have my data here. I'm going to hit stat and tests and z-test. Now I have stats, not data, so I'm going to go over to stats and hit enter. And now it asks for mu naught. Mu naught is the mean that is in my not statement. So since this says 30, this one also needs to be 30. My standard deviation is 2.5. The mean that I obtained is 31, and my n value was 50. What it's looking for down here beside the mu is what is written in my alternative hypothesis. So since this is pointing to the right for greater than, I need to choose the greater than symbol over here. Make sure you hit enter so that it's highlighted, and then go down and calculate. So now I have a z value. This would be my standardized test statistic of 2.828. I have a p-value of 0.0023. And I'm going to go ahead and label in my z value on my chart. 2.828 ends up being up here. It's larger than the 2.326. So I'll end up putting it up here, 2.828, and that is going to be in the rejection region. So I am going to be rejecting the null. I'm going to be rejecting the null. That means I'm going to support the claim. If I reject the null, I support whatever's in HA, or the alternative hypothesis. So in summary, I would say that my evidence does support the claim that the mean score is more than 30.